So today we'll continue with our bigO notation, and today is the last day I will do the bigO notation. So this is something, this is something we noted down about the bigO notation. We have O of 1, O of log n, n log n square, n exponent constant, and constant exponent n, and the n factorial, that is factorial. So it is good to keep your code below this level. Okay, ideally it should be on, but this is little bit acceptable, and this is not really acceptable. If you create your solution with the n square, then that solution is not acceptable unless we don't have any other solution in all of these. Then you can go with n square or this and this. But if somehow you can find the solution below this, that is the best, or below this is the average. And if you don't get the solution in this, then you can go to higher bigO notation. So that is the case. Now we'll see some more examples of each of them, and then not each of them till quadratic or till polynomial. I'll show some example. These two are not the scope of today's class, but when we reach to that point, I will show you some examples of these two also. Okay, so this is something I deleted. So let's say if I have function, for example, a, and this function takes the parameter n, and if I write down the for loop, and I write down the for loop, console.log I is I, something like that. So what is the complexity for this one? Can anyone tell me? What is the complexity of this one? On. Why it is on? Because we are looping n times. If I try to repeat this for loop again, then what will be the complexity of this function? On. Okay, so even if I put the for loop, but these are the two separate for loop, they are not nested, so the complexity of this is also on. If I put for loop again third time, then what will be the complexity? On. Since this for loop is also outside the another two for loop, so we have this for loop, let's say n, second time 2n, third time 3n. So even if it is a 3n complexity, we always say it as a O of n. So the complexity is O of n for this function. Okay, now what will happen if I put this for loop again inside the first for loop, and I will change the variable to j. So what is the complexity of this for loop, this part? So what is the complexity of this part? On square. That is correct. Since we have for loop and we have nested for loop, that is a for loop inside for loop, therefore the complexity of this for loop is O of n square. And let's consider the complexity of this is n. So if I take both the complexity, it goes like O of n square plus n, because let's consider this is n complex, this is n square complex, and we have n square plus n. We ignore the smallest part, we only consider the highest number, so the overall complexity of this function will be n square, O of n square. Okay, so this is the complexity of this one. So let's create another function, and I put this for loop also inside the second for loop. So we have 3 for loops. Now here it's a k. So what is the complexity of this function? What is the complexity of this function? We have for loop, and then third nested for loop, n cube. That is correct. The complexity is n cube because we are going 3 times nested for loop. Okay, so let's forget about the n cube. Let's consider n square only. So now we have 2 for loops and the complexity is called n square. What will happen if I go second for loop n by 2? So I'm not going till n, but I am going till half of the n. So what will be the complexity of this function? It's not log n. This part is log n. This whole part will be n log n. Okay, so this part is not going to n. So I cannot say it's n square, because if both of them goes to n, I can say n square. But this part goes half of the n. Therefore, it is n log n complexity. What will happen if I remove this for loop and I will go to half of the n in the first for loop? What will be the complexity of this one? It's a log n. Now we don't have n log n, we have only log n. So it's only log n, right? It's not n log n because we are going half of the n. Therefore, this one is log n. Is it clear? Okay. So if I remove this for loop, if I have only variable var a equal to 1, what is the complexity of this function? O1, because this function is not dependent on n, therefore the complexity of this is O1. So this is the O1, and if we put one for loop, okay, let me write down this. If I go to n I plus plus, sorry. If I go n by 2, that is half of the n. So this one is O1, that is the constant. And this one is going to the, we are using the for loop, but we are going to the half of the n, that is the not exactly n. So this becomes O of log n. And here we are going till n. So this will become O of n. And here, if we go to first loop is going to n, second loop is going to half of the n. So this will be n log n. And let's go to the third one. First one is going to n, and second one is also going to n. And this one is n square. So this one is the least complex. This one is more complex than first one. This one is more complex than second one. This one is more complex than this last one. And this one is more complex than this one. So out of this 1, 2, 3, 4, 5, fifth one is the most complex. First one is the least complex. Generally, when you go for interview, they will give you problem which looks very simple if you go with this n square, and you will be doing that problem quickly using this big O notation. But then you will be rejected from the interview because you have used two for loops and you have not used the these one of this big O notation. So whenever you will go for interview, there will be always one solution which can be done easily using the n square complexity. But then you don't have to do that using the n square, and you have to ask more questions and you have to think in mind to come up the solution which can be any one of these ones. Generally, if you go for Facebook interview, they will reject you immediately if you go with n square solution. So whenever you go for Facebook or Amazon or big company interview, try to avoid this two n square complexity and try to go with this. Because whenever they will give you solution problem, it it can be solvable by any one of this big O notation, and so they give purposely that developer should start writing this one and they can reject you. So if you can think this immediately in the interview, maybe the 15 minutes to 30 minutes, then you will get the round clear and you can go to another round. So that is my suggestion, not to go with this solution in the interview. In practical life, there may be some complex problem which cannot be done without this part. But when you go for interview, they will always give you some problem which can be done using this way or this way. So you have to find a solution which can be done in either of this way. Ideally, it should be less than ON. But if you cannot do, go with this. If you cannot do with that, go with this one. Okay. So that's the basic information about the big O notation. Let's talk about the big O notation for the objects and array. So we will now talk the big O notation for the objects and arrays. So I will show you again how we create the object, and then I will tell you okay, so those who are busy, they can leave and I can explain them. They can watch video whenever it is ready, but it's okay. So let's go with the big O notation of objects and arrays. How to create object? I can create object var a equal to, I will use curly bracket. Whenever I have to create the object, I will use the curly bracket. There are other ways also to create the objects which we have seen in the past, and I don't want to repeat that now. I will show you one easy way to create the object. So I created this object A, and I can put some key value pair in it. For example, first name equal to Jack, last name equal to Bauer, and age equal to 44 maybe, and is married equal to false, something like that. So I created the object with key and value, and this value can be string, numeric, array, another object, or function, or boolean like this one, or numeric like this one, or string like this one. So this can have, the value can be of different types. So I created this object. Now we have to see what is the complexity big O notation for the objects. So when I insert anything in the object, it is of big O notation of O1. So for example, this is the object. I want to insert another key. For example, I will say a dot hobbies equal to x, y, z. Okay, so I created inserted one object, one value, key value pair in the object. So the insertion always take the big O notation of O1, right? It's a O1. Let's say if I want to remove something from the object, so I will say delete a dot hobbies. This one will also take O1 complexity. If I want to search in the object, search in object. Searching means I have to go through all the key value pairs. I have to go all the key value pairs and I have to find whether Jack is there or not, Bauer is there or not, Jack is here or Jack is here or Jack is here or Jack is here. That means I have to go through all the key value pairs. Therefore, what will be the bigO notation for search? What is the bigO notation for the search? On, right? Because I have to go through all the n elements of the object. Therefore, the bigO notation of the search is On. And if I want to access, for example, if I want to access whether it's a married or not, so to access it, to access any element or any property, we'll say any property in an object is of bigO notation of O1, because this one is saved in the memory. Whenever I want to access last name, it immediately goes to that memory location and give me. It does not have to loop through all the elements and give me the result. So the accessing any property is also bigO notation of O1. So only thing is in the search we have the bigO notation of On. Otherwise insert, remove and access is the bigO notation of O1. Okay, this is what we see in the object. Okay, let's go to the okay, let me ask you now some questions. Okay, let me do the array also and then I will ask question. Otherwise it will be too simple. I just now explained you will immediately answer it. Let's go to the bigO notation for the array. So in array we have values which are starting with the key of 0 and it goes to, so this is the 0 key 1 2 3 4. So index is 0 1 2 3 4 and it is a numeric ascending order. So this is the array we created and assign it to the variable A. Okay, so this is the A variable. Now we will see what is the bigO notation for all the operations in the array. So what happens in the memory when I create array? So when I create array, a memory location is created in the location is created in the memory, and it has the ascending value. So 0, 1, 2, 3, 4, 5. Let me show you in the diagram. 1 second. Okay, let me show a diagram what happens in the memory. Okay, so whenever I create a array, so these are the memory location, right? These are the memory location in the computer. And whenever I create the array, for example, I create the array A, and let's create this one A, and this is the array. So in the memory, it knows at the 0 index, it will keep the value some, for example, 3, and then they'll be followed by other locations in the memory, and it will be automatically assigned of index 0, 1, 2, 3 in the memory. So whenever I want to access, let's say 2 element, it will immediately knows which location it has to go. It does not have to go through all the n numbers to find the where is 2 is there. This 2 key is always there handy, and computer knows where to go exactly and get this 2 number. So whenever I want to access any element in the array, for example 15, I will say this is the key of 0, 1, 2, 3, 4. So if I want to access 15, I will say A of 4. So whenever I say A of 4, it immediately knows where is the 15. It does not have to travel whether it's a 15 year, 15 year, 15 year, 15 year, 15 year, because we are accessing with the key. Whenever we access with the key, it immediately knows where is the location of that element is, and it will give the result immediately. It does not have to go through n numbers to find the solution. So to access element in an array is always bigO notation of O1 constant, because it does not have to loop through all to access the element by index. Is that clear? Are you getting me what I'm saying? If I want to access it, it goes directly to that one and give me the result. So the accessing the element in array is always O1. That is a bigO notation of O1. Now what will happen when I want to insert it? So let's say I insert it with push method. Push method insert the element in the end at the end of the array. So when I say a dot push, for example 4, and now if I check, and the last element is 4, and this element is 4 is added in the array. So whenever I use the push, since computer knows all the memory location of this key index, so it has to add one more in the memory. So it will not search or loop through all this and try add it another one in the memory. So it will directly knows that this is the last one, and it has to add one more here. So it is always O of 1 complexity, because whenever we use push, it has to only add in the end. It does not have to rework on this all the old elements, and that is the reason we have O1 complexity for the adding the element using the push. If I want to remove the element using the pop, for example pop, a dot pop, if I remove it from the end, then also computer knows that this is the last element. I have to remove it, and it does not have to touch any of the other elements. So it is only one operation to remove this one, and therefore O of pop is also always O of 1. That is the complexity of O1. But what will happen if I use a dot unshift? So 1 is added in the beginning of the array. See, 1 is added in the beginning of the array. So whenever I use unshift, 1 is added at the beginning of the array, and then all these elements are moved one by one. So first 0 element is 1, and all the elements are moved now. 3 is moved to index 1, 6 is moved to index 2, 9 is moved to index 3, 12 is moved to index 4, and 15 is moved to index 15. Therefore, all the elements are moved one by one, because first 0 element is accommodated by the new element, that is the 1. Since everything has to be moved when I unshift it, when I add it from the beginning, therefore the complexity of unshift becomes O of n, because it has to add the element at the beginning, and it has to move all the elements one by one with the new index, like this. These are the new index. Therefore the complexity of unshift is O of n. Same thing with a dot shift. When I remove the element from the beginning, that is, if I remove the element from the beginning, then what will happen? The 0 element is gone, and 3 is moved to the 0 index, 6 is moved to the 1 index, 9 is moved to the 2 index, 12 is moved to 3 index, 15 is moved to index 4. Therefore everything is moved one number ahead, and therefore it is also the complexity is O of n. Why? Because everything is moved, and once we touch every element, that means it is of complexity of On. Okay, let's see. So we have seen if we remove from the end of the element. Now tell me, if I remove the element from the middle of this, let's say 9. If I want to remove the 9, what will be the complexity of it? O1 or On? On. If I want to remove the element from the middle, that means I will remove this element and then all other elements have to be shifted in this place. So the complexity becomes On. If I want to search the element, for example, I want to search where is 12 or where is 3, where is 15, what will be the complexity of it? What will be the complexity of search? Search is On. The reason is it has to go through all the elements and it has to find the exact value which is matching with the value I provided it. So search is also On, and everybody gave the right answer. That means you have understood what I was saying in this whole class. Okay, now I will ask few questions. This is done. Whatever I said, it's done. Okay, there is one operation in the array. It is called for each. It goes through each element and does something. What is the complexity of this one? On. It's On because it goes to all the elements of the array and give the some result. So that is also On. Okay, let me ask now a few questions. What is the big O notation? What is the big O notation for adding a key and value into the object? If I want to add a key and value inside the object, what is the big O notation? O of 1. Answer is O of 1. That is the constant. I already explained you. Second question. What is the big O notation for accessing a key in the object? If I have first name, last name, age, I want to access first name. So accessing also, I have the big O notation of O1. What is the big O notation for removing a key and value from the object? Removing. So removing also is O of 1. What is the big O notation for searching in an object? O of n. So for the searching, it is O of n. So this is all about objects. Let's ask some question on the array. What is the big O notation for pushing into an array? I have to push an element in the array. Push is O1 because there is only one operation we have to add in the end. Okay, let's ask another question. What is the big O notation for shifting, whether unshift or shift, into the array? In the array, it's On because we have to move all the elements in an array, so it is On. What is the big O notation for each function in array? It is On because we are going through each element of the array. Therefore, the big O notation is On. And if I want to access any element in the array, that is also O1. I don't want to ask that one. Accessing a key in an array is O1. Okay, so this is all about the big O notation and big O notation for object and array. Okay, so I will tell you some more thing now. Regarding how we will proceed. Do you have any questions in this one? Is it clear or you have any? Okay, so it should be clear. Otherwise, you won't be able to, because whatever problem we do, in many problems I will ask you what is the big O notation, and based on this logic, you have to answer me whether what is the big O notation for each function. And in exam also, in interview also, whenever you are done with function, the examiner will ask you, or the interview person will ask you, what is the big O notation for that function. Okay. So I will be doing lot of problems here from next week. Okay, so lot of problems I will be doing. So how to do those problems? So here I will explain, for example, one problem. You have to write down that problem after the class whenever you have time. Write down that problem 10 times. Okay, 10 times. And don't write down 10 times without looking. Every time whenever you write down, you have to write down by looking at the example which I have given you. Don't write down without looking. Write down 10 times because it should be, you should have the habit of writing that problem by looking, and one time write down without looking. So first 10 times write down by looking at the problem. So for example, I don't copy paste, okay? You have to write down like this manually. For example, if I give the problem this function sum of a, then return a plus b. Okay. So this is the problem I have given you. So what you have to do? Okay. What is the syntax error? Okay, because of this there is syntax error. So what I have given this problem. So what you have to do when you are free at home after the class, you have to write down this function sum again a comma b. Don't copy paste. Write down this problem like this, return a plus b. Okay, one time done. You can start with the sum, maybe you can put 2 so that you know how many times you have done. And do it again. Write down this. By looking at the above solution, you have to write down by looking. Return a plus b. Okay, sum 2. Like this, write down 10 times. And finally, after 10 times, you clear everything and write down without looking. So here I'm writing without looking. So that you should remember that problem thoroughly in your mind. A plus b. That way, you will remember this problem without looking, and you send me the last solution which you have written without looking. Maybe you may do some mistake when you do without looking. That's fine. Mistake is okay. Okay. So if you have done mistake, it's fine. It's okay. But once you write down without looking, mistake is fine, but at least you tried. That is what I want. And then if you do mistake, you can go back and check what mistake you did. So when you do something which is without looking, you have to send me that solution to me that you have done this without looking. But before doing the without looking, you have to do 10 times that same problem. We will be doing more than 200, 300 problems. And all the problems you have to write down in this way. Okay, and 99% of time in interview you will get the problem out of this only, whatever we will do. Okay, so it will, because these problems are limited on the internet, and the interview person has also done these problems. He cannot create his new problem from his mind. He will only look into whatever is there on the internet, and we will do all the problems which are available on the internet. So basically, you will get one of them in the interview. So once, if you have done 10 times each problem, that means you are very thorough in that problem, and you can solve that problem immediately when the interview person will ask you. Okay, now another question is, how can someone apply to Google or Amazon? So generally, you get in Amazon, you have to go to Amazon website and search for the job in Amazon, and let's see available jobs in Amazon. Let's check if we have anything. Okay, let's see if there is job. Maybe I can say React.js job. Okay, here I got one here. See, Amazon job, front-end engineer, React and JavaScript. So this is in the Seattle, Washington. I will give you the link. If you are good in React now, you can apply. Okay, so this is something front-end job in the React, Amazon.